All right, guys, this is lesson 9.6 in our purple book. And we are working on modeling equivalent fractions. So equivalent fractions mean fractions that are the same. And now this is my second go at this video. The first go, my phone died partway through and it killed the video. So some of the stuff is already filled in, but I think it'll still work okay. So this one, it has a little bit of an investigation, which uses a sheet of paper and a crayon or colored pencil. If you have one and you want to do it with me, you can. If you just want to follow along, that's fine too. So here we go. Two or more fractions that name the same amount are called equivalent fractions. You can use a sheet of paper to model fractions equivalent to 1/2. So equivalent fractions, pretty important word. We want to make sure we circle it. And then it means the same amount. So equivalent fractions are the same. They name the same amount. So let's move on to our model. First, we're going to fold a sheet of paper into two equal parts. So of course we just fold it in half. And then we're going to open the paper and count the parts. So here I have my folded in half piece of paper, and I'm going to open it up. And this one, because I had started already has some writing on it, but you can see there's 1/2 and 1/2. So together that makes a fold. So there are two equal parts. Each part is 1/2 or one of two of the paper. Shade one of the halves and write 1/2 on each of the halves. Got that? If you're doing it at home, go ahead and do that part. Next, we're going to fold the paper in half 2 times and then open the paper. So I've got my paper. I folded it in half like I did before, so it's in half. And now I'm going to fold it again. It's a little trickier doing it one-handed than you would think. Okay, so we folded it again. How many pieces do you think we're going to have? Make a guess. Okay, and we'll open it up. Okay, so now we have 1, 2, 3, 4. And what I'm going to do, I'm going to take my pencil here and draw across my new line so that we can see it a little better. It's not a perfect drawing, but there we go. Okay, so we have 1, 2, 3, 4 in our hole. So let's see. Now there are 4 equal parts. Each part is 1/4 of the paper. So we're going to write 1/4 on each of the fourths. So on my paper, I'm going to write 1/4, 1/4, 1/4, and 1/4. So I have 4 1/4. Okay, check. We did that. Now look at the shaded parts. 1/2 equals how many fourths? And you can see the answer right there because I already wrote it. But if we look, so we have 2 halves, one of them shaded, and we look, there's 2/4 in 1/2. So 1/2 is equal to 2/4. Okay, lastly, we're going to fold the paper in half 3 times. So again, folding it in half that made our halves. I'm going to fold it again. That's 2 folds, which made our 4s. And now I'm going to fold it again. Okay, make a guess. How many pieces are we going to have left? Okay, unfolding it. And now I'm going to draw a line so we can see where we did our fold. We have a fold, woohoo, right there. And then we have a fold down here at the bottom. Goes across here and right across there. Okay, so now we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have 8 equal parts. So now we have 8 equal parts. Each part is 1/8 or 1 out of 8 of the paper. So we're going to write 1/8 on each of the 8ths. So I'm going to write it up kind of to this side. 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, and 1/8. If you're doing this on your own, you should have 8 1/8s to make a whole. So if we look here, so we're finding the fractions equivalent to 1/2 on our paper. 1/2 we know is equal to 2/4. And so if we look at our half again, our shaded area, we have 1, 2, 3, 4 8s. So we know that 1/2, 2/4, and 4/8 are equivalent or equal the same. And now we're going to flip over our paper. Okay. Drawing conclusions. Explain how many 1/8 parts are equivalent to 1/4 part on your paper. So before you look at the answer I wrote, so we know that 1/4 goes to here. So I'm going to go ahead and make our little squiggly line so we can really see where our 1/4 is. Here's 1/4. So how many 1/8 do we have in a quarter? 1, 2. So 2/8 in 1/4. So I wrote on my paper 1/4 equals 2/8. Now in the 1/4 part of the paper, there are 2/8 or 2 1/8 sections. Check? Check. Okay, analyze. What do you notice about the numerators changed for the shaded part as you folded the paper? So if you remember, on a fraction, we have a numerator on the top and a denominator on the bottom. So right now we're looking at our top number, the numerators. So let's take a look back at our paper. So we had 1/2, 1/4, and 1/8. So each of our sections is all 1/2, 1/4, or 1/8. So our numerator is that top number. So our numerator for all of these is what number? 1. Our numerator is 1. So did we notice that the numerators changed for the shaded part as we folded the paper? So that's a little more complicated. I was answering just for overall. So the shaded part. If we look, we had 1/2 and 2/4 and 1, 2, 3, 4. 4/8. So it did change. We had 1/2, we had 2/4, and we had 4/8. So what do we notice about those? As we folded it more times, our numerator gets bigger. So I'm going to write numerator gets bigger. Okay, so what does this tell you about the change in the number of parts? Well, I know that if these are the same, how many parts do I need? Well, this one, it's 1 out of 2 parts. This one is 2 out of 4 parts. This is 4 out of 8 parts. So what does this tell you about the change in the number of parts? That it increases, right? It's going to get bigger because those numbers are getting bigger. So how did the denominators change for the shaded part as you folded? Remember, our denominators are bottom number. So what happened to our denominator? As we folded, it also got bigger. Our number got larger. So our denominator got larger or bigger. It increased. What does this tell you about the change in the size of the parts? Well, let's see. So this part is half the paper. This one, if we look, is 1/4 of the paper. These ones are 1/8 of the paper. So what happens to our parts? Do they get bigger? Do they stay the same, or they get smaller? They get smaller. Every time we folded it, those pieces get smaller. So the parts get smaller. So as our denominator gets bigger, our parts get smaller. And that's a pretty important thing to know. Okay, making connections. We can use a number line to find equivalent fractions. So we're going to find a fraction equivalent to 2/3. So if we look here, 2/3 is right here. We can use our fraction strips, which I've got right here for us. Okay, draw a point on the number line to represent the distance 2/3. So I'm going to put it right there. So I know that that's 2/3. Sorry, I was going to shake for a second. Use the fraction strips to divide the number line into 6. At the end of each strip, draw a mark on the number line and label the marks to show 6. So if we dig over here, that's not quite going to work for us. So you know what I'm going to do on my hole, because we know 3, 3 is a hole, I'm going to use 6 up here. So I have my 6, and then this was thirds, so those are my orange pieces. So I'm going to grab those, put those across. So I'm using my fraction strips to model this. So let's see. So if we were looking at 6,